Hi everyone, in this video, let's solve LeetCode problem number 11, container with most water. This is a really popular interview question and reading question. We are given an integer array height of length n. So there are n vertical lines drawn such that the two endpoints of the ith line are I comma 0 and I comma length height of I. We have to find two lines such that together with the x-axis they form a container or a rectangle such that it contains the most water. So we need to return the maximum amount of water that a container can store, and we can't slant the container. So this is the gist, and here is an example, right? So if we translate this into an array, it would basically get 1, 8, 6, 2, 5, 4, 8, and this would be 3, 7. So let me just cross check so that we don't make any mistakes. So 18625 1862548. Yes, so this is correct. I'll write it in one line here. Okay, so the brute force solution is as follows, which is quite easy and intuitive. Uh, so we would have an I pointer here, j pointer as I plus 1, and now we would find the area where we can possibly store the water. So the problem with this is that, see here, we are actually constrained by the lower of ing, so the lower height of ing, because if we try to store water which has an area more than the height of I, right? So the water spills, so we can't store water here anymore. So that's why we are constrained by the uh, lesser of the heights between I and j. So constraint by min I comma j. Okay, but the width, regarding the width, so there's no problem. So this would be the width. So 0, 1, 2. So the width would be 2 minus 1, but the height would be minimum of I comma j, which is 1 into 1, that is equal to 1. So in the next iteration, what we do is, so we keep I here, then we move j here, and then we do the same thing. So we take I minus j as the width, and so the minimum of I comma j as the height. So this would be our height here. So the amount of water stored would be minimum of I comma j into multiplied by j minus I. And finally, we keep moving this j forward until the j reaches here, doing the same calculations, and we can keep a max area. We can keep a max area variable to calculate what's the maximum area that we found so far. So the time complexity of this solution, the worst case time complexity would be of n square, because we would be having two loops, one for I, the other one iterating through j, which starts from I plus 1. Okay, now coming to the optimized solution, we can use technique called two pointers. So instead of having the pointer here, this place, We would rather keep one pointer at the start, the other pointer at the end. Let us see how that works. Okay, so now I will keep one pointer here, I, the other pointer here, j. So likewise, like our previous formula, right? So what we basically check is the width of our container right now, which should be j minus I. But in the height, as you can see, right? So the water, you can store water only here. So only in this part of our entire container, because we are constrained by this building a vertical line of height 1. So this is where we can store the water. So we can essentially calculate the amount of water as uh, so it would be min of height of I comma height of j multiplied by so height of j minus height of I. This way, so this would be the area, and again we keep a max area and do the comparison. So if the area is greater than the max area, then we initialize max area now to area. That's how we do it. And in the next iteration, what happens is we basically need to decide how to move our pointer forward. So if you have I here, j here, so like if if you apply a bit of common sense, right? So or a bit of um, intuition, moving which one of these would increase our area. So now we have I is equal to 1, j is equal to 7. So if we move j inwards, if we move this inwards, what would be our height? So what would be our area? Sorry. So the area would actually decrease, right? Because our height remains the same. The height is 1, but the width decreases. So instead of moving j inwards, we keep j here, but we move I forward. So basically, our whole intuition is that for the area to increase, whichever is the minimum heights between I and j, we move that forward, so that the one which is the building which is or the vertical line which is larger than the other one remains fixed, and the small we try to increase the smaller one uh, gradually, so until it becomes large enough to find the maximum area. So now the area in this case we would have is j minus I multiplied by min of I comma j or h of I comma h of j, the same formula. So this is 0, 1, 2, 3. So 9 minus 2 multiplied by min of I comma j. So I here the value is 7 and j value is also 7 here. So both are 7. So this would be 7 multiplied by 7, that is equal to 49. And now our max area until now was 1, right, in the previous iteration. So now, so 49 is greater than 1. So now max area will be updated to 49 units. And similarly, so if you keep moving forward, now we have I here and we have j here, so both are same, or no, actually both are not same. So here I is 8 and j is 7, the peak. So which one of these is smaller? So j is smaller, so we move j inwards. So j next time would come here, and then again we would calculate the area this way. Okay, calculate the area this way and store it in the max area variable. And now, right, so next in the next iteration, what would happen is, our j would be 3 and our I would be 8. So I think this deserves a better explanation because I didn't cover a case where I is equal to j, right? So let us assume I, this is j. Okay, now they are both at the same height, right? So what do we do now? So in this case, our area would be j minus I times min of I comma j. So it's 0, 1. This will be 1, 2, 3, 4, 6, 7. So 7 minus 2 multiplied by min of I comma j would be 8 because both of them are same. So this would be 8 times 5, that is equal to 40 units. Am I right? So yes, I am right. So now the question is which one to move forward, right? Either we move j or either we move I or we move j. So it really doesn't matter, but I mean, because anyways you'll since they're given that there's uh, only one possible solution and not more than that, so it really doesn't matter. But what you can do as an optimization is just do a forward lookup, right? So you can just keep another variable which goes front and checks if this height, which is after I, right, at I plus 1, if it's greater than or lesser than the height at j minus 1. So if this height is greater, of course we would be moving I forward to increase the maximum area rather than bringing j to a vertical building which has a lesser height. So that's the whole intuition, but it doesn't really matter. Like, I mean, you can dry run and check it out. You would get the same answer. So generally, like in like other two-pointer problems, we keep iterating until I is less than j. So that's kind of the explanation for this problem. Okay, so yeah, so this would be your max area, and here you would have to check, right? So this 40 is less than our max area of 49. Okay, so we can't go further. That's one thing. Now coming to the code, it's really damn simple. So we keep L and R 0 and height minus 1 like usual, and then this result would be the max area while L is less than R. Here we check, right? So res is equal to max of this result, and uh, which is a current max area variable, and then we apply this formula. This is the width, this is the height. If height of L is less than height of R, of course we move L forward to make it a bit larger than it was before. And if height of L is greater than height of R, then we move R inwards. But even if both of them are equal, you can either move L inwards or R inwards, and you would get the same answer. So here, in this case, I have moved R inwards, and once uh, this loop finishes, we just return res, which will hold the maximum area. So that was all for this video, and see you in the next one. Thanks.